Welcome back. In this lesson, we're going to look at orogeny, which is a strange word nobody knows. Essentially, it's the making of a mountain range or a chain of mountains. So how does a 100-mile or 1,000-mile range of mountains occur? We're going to look at just the mechanisms of that. What does it look like? What are some of the obvious answers of how you could make whole chains of mountains and why mountains would form in the first place? Why would you find mountains in one place and not find them in the other? So let's look at some examples. A mountain made by uplift or whatever, if an entire range of mountains is made, there's kind of a procedure for that, and that's called orogeny. And a lot of times this happens between plate boundaries. So if you have two cracks, remember the plates are like a boiled egg that's cracked all over the egg, and each of those layers of the shell is one plate, and they're running into each other. A lot of times one plate pushing into another plate will shove the other plate up. Whichever one sinks down low and whichever one's risen up, you can get some uplift, and that uplift is the beginning of some making of a mountain range. Also, you could have some volcanoes that result as these plates are shoving together. Those volcanoes can be part of making these mountains. And then you have some other things that are going on. So we'll kind of look at these one at a time. So remember, if you were to have a belt of mountains, or we would call it a range of mountains, a lot of times these mountains will be formed at the same time. They basically are either buckled, where you have kind of a big car crash between plates, or all lifted up in the case of, say, one plate sinking down underneath another plate and rising the edge of that plate up. That's one way that a whole range of mountains can be made at once. Okay, so an orogenic belt is just another name for a mountain range. All right, so if you've got a convergence, remember convergence is where it's coming together, then you're going to have compression, and compression is a squeeze. And if you were to take two pieces of clay and compress them together, you're going to get that clay to buckle. You're going to get it to kind of bulge, and that is really what a mountain is. A mountain is a bulging of crust. So you have a normal crust, and if it comes together and buckles, then it's going to lift up higher than the level of the surrounding crust, and that is called a mountain. All right. In that mountain making, all kinds of things can happen. You can have cracking, which is faults. So you could have areas where earthquakes could occur because you have cracks and large cracks in between different areas. Of course, if you have two plates moving together, you already have a fault because they're continuously breaking apart. Even if they were fused, they would break and break and break, and you could have earthquakes there. You could have metamorphism, where you have intense pressure because it's coming together pressurized, and so you could reform and rechange the structure of different kinds of minerals. You could also have volcanoes that occur here as one crust is sinking down and then melting, and then you have basically a lava lamp happening there with you've got melted stuff that could rise or lower in the surrounding, get a convection current going. So all kinds of things could happen in that area when you converge plates. So now the types of plates that converge would mean kind of what's going on. So let's look at the different types of plates that can converge. So the first type of plate is you have an ocean plate and another ocean plate, and they're running into each other. Well, if you force it with enough pressure, one is going to rise and the other is going to sink. Okay, one's going to subduct. It goes underneath the other one. In that subduction, it is possible that the plate that's not being subducted is lifted up slightly, making the ocean a little less deep in that area, and the crust that's going deep down into the mantle is actually getting hotter because it's hotter lower down. It's being shoved down in there by the movement of the ocean plates, and then it could melt some of that plate. So you're going to get some of that plate that's being melted, And as it's melted, you're going to get convection currents inside that melted rock, and you could end up with a magma chamber that could find its way through a crack as a vent, and you end up with a volcano. A lot of times the volcanoes formed by two plates coming together, ocean plates, even though that there's water above them, will form an island arc. So essentially 1, 2, 3, 4, 5 volcanic islands all in a row. And so if you look, where are these island arcs, you're going to see in the South Pacific. You've got lots of Micronesia, you've got lots of Indonesia, all of these island nations, kind of one after another, all of these being volcanic. So you can kind of see them on the edge of that plate, even though that the ocean goes beyond them. They're islands, but the plates underneath the ocean have somehow run together. Okay, so that's an island arc complex, is actually called. Now, if you were to run an ocean plate into a continent, that's a little bit easier because the continent is less dense. So the ocean plate will always subduct under a continent because the rock that makes up that plate is denser, and so it rides lower in the mantle. And so if they were to crash together, one would go under the other. So the ocean plate normally would subduct. Well, when it subducts, it raises up the lip, if you think of it, of the other edge of the plate. So the plate that's riding higher is actually going to be lifted up. So that's the first part of this mountain making, okay, this orogeny. It lifts up the edge of that plate. It can also melt, just like when you saw the volcanoes being made with the ocean plate. It can melt the rocks that are being subducted. And the rocks that are being subducted would melt, form magma chambers, and then eventually find their way out. And even though that this is not in the ocean anymore, it's on the land, you can end up with a big ridge of volcanoes. You're going to see that along South America, the west side of South America, and the west side of the United States. You're going to have volcanoes all the way up that, because the Pacific Ocean is actually sinking down underneath the west coast of the U.S., and the west coast is raising up, the west coast of South America is raising up, and you have volcanoes there. Those both of them happen at the same time. Now, a lot of times too, you can fold. You can have folding there. You can have crinkling there. So, as one is being shoved down, imagine taking two pieces of aluminum foil and shoving one under another. You can have buckling. You can have to where they grab and essentially fold that material. And so you can have things like metamorphism going on there, crinkling of the rocks, bulgings of the rocks simply because you're folding them in on themselves. That's very possible. And then other more interesting, I suppose, things geologists would be interested in, of what kind of rocks are found where. How is it possible that I'm finding marine crust on the tops of mountains, really high mountains? Okay, well, if I have two continents coming together like India and Asia, all right, and I have a buckling there, I think of what's going on between India and Asia, and I go, oh, okay, the Himalayas, that's the highest mountains in the world, are being driven up because I have two continents going together, and one continent is actually, India, is actually forcing underneath Asia. And both of them are it's not like an ocean crust that's normally more dense. These are both oceanic crusts, or both continental crusts, and so you're going to have very, very high mountains. So the highest mountains in the world are found where two continents are actually crushing together and raising them up. And all kinds of things happen. You can end up with marine rocks on top of these high Everest mountain type mountains.